Acids and bases. Kb is the base ionization constant. For a general base represented by B, it reacts in the presence of water to produce the ions BH plus and OH minus. The equilibrium expression for Kb is given below, where Kb is equal to the concentration of the product ions multiplied by each other divided by the concentration of the base. Water is a liquid, its concentration does not change, and the value of it is equal to 1. Note for Kb, these are ionization reactions in water. A hydroxide ion is always on the product side.
Here are some examples of weak bases that use Kb. The sulfite ion reacts with water to produce hydroxide ion plus H2S, the conjugate acid. In writing the chemical equation for base ionization reactions, you need to note, first, water is a reactant. Second, a hydroxide ion is always a product in this reaction. Here's another example of an azide ion, the base, reacting with water to produce the hydroxide ion and the conjugate acid of the azide ion called hydrazoic acid. The relationship between Ka and Kb. This is given by the equation Ka times Kb is equal to Kw. To derive this equation, there are two chemical equations that are used: acid ionization and base ionization. In this example, note that HN3 hydrazoic acid is used as the acid in the acid ionization. The second chemical equation uses the azide ion, the conjugate base of the above acid, hydrazoic acid, for the base ionization. Writing the equilibrium expressions for Ka and Kb are given here. Multiplying the concentration terms between Ka and Kb and canceling concentrations that appear in both the numerator and denominator leaves the concentration of hydronium ion and the concentration of hydroxide ion. The product of these two concentrations is equal to Kw, so Ka times Kb is equal to Kw. One question is, if the pKa of HN3 hydrazoic acid is 4.75, what is the Kb for its conjugate base? The relationship between Ka and Kb. This was derived in the previous slide. pK of hydrazoic acid is equal to 4.75. What is Kb for its conjugate base? Find the Ka. Ka of hydrazoic acid is equal to 10 to the power of negative 4.75. This is equal to 1.78 times 10 to the minus 5. So the Kb of the azide ion is equal to Kw over Ka. This is equal to 5.62 times 10 to the power of minus 10.